Hi class, this is our 7th online lesson in statistics and we are doing chapter 5. This is the second part of chapter 5. We finished correlation. Now this is the next thing, regression. So now what is regression? Regression not only gives the correlationship between the two parameters but also the equation of the relationship. So we get an equation in correlationship to make the relationship between the two parameters. Okay, so you will not only know now that there is a strong positive or weak positive or no correlation or negative correlation, you will also have an equation now so that we can predict. So we can, like for example, if I have y equal to mx plus c, the equation of a straight line, regression is also like a equation of a straight line. When you have the value of x, you can substitute the value of x to predict the value of y. That is the idea. So same, instead of y equal to mx plus c, we write here y equal to a plus bx, where b is the same idea of gradient, a is the same thing as the y-intercept. Okay, this is what is written here, and this is the same thing we studied in our previous lesson about correlationship. Independent variable is your x, dependent is your what is plotted on the y-axis. Okay, the formula now. The equation of regression line of y on x, see, very important, of y on x. If it is of y on x, y should be the subject, so y equal to your mx plus c or a plus bx. If it was of x on y, x will be the subject, and so on. Now in this you need to find the gradient, which is b, and the y-intercept, which is a. So you need to find a and b. The formulas are like here. We know gradient is the y distance over the x distance. I'm just trying to make a connection. So it is y divided by x. You just put extra x here. So this is just so that you can remember the formula. So s xy divided by s xx. This is your b. And to find a, just rearrange this formula, make a the subject. And instead of taking y, we take the mean of y and we take means. This is mean of x and mean of y, and that's it. Okay, before we go on with this example, let us see what they're talking about. Okay, this is an example where they are testing how you find independent and dependent variables. So first of all, the number of operating theaters and the number of operation carried out. Now within these two parameters, what do you think is the independent and which one is the dependent variable here? Okay, definitely how many operations will be carried out depends on the operation theater. So this depends on this. That's why you see this is your independent variable and this is your dependent variable. Same thing here, you try it on your own. Okay, now a proper example. Now this is exercise 5b from your book. Draw a scatter diagram. Same, you can take it like a coordinate 32, 18, 44, 13, plot it, and then the question says calculate, this person calculates a regression line of n on a. That's why n is a subject, and without further calculation, explain. Okay, let us take the diagram first. So when you finish, you will see the diagram like this. So if I draw the line of best fit, you know what is the line of best fit, correct? Somewhere in the average line, somewhere in the middle, if you draw a line of best fit, it tells you that there's a negative correlationship in this. And since there is a negative correlationship here, the gradient, we know from our concept of straight line, if a line goes down, the gradient should be negative. Hence this gradient should be negative, which is the mistake. Explain why regression is incorrect, because this should be negative obviously, and that is a problem here. Next. Okay, so find the equation, the equation of regression line of m on v. So m equals to, this is the equation, but very important to note when they write something like this, v is in thousands and m is in millions. So you have to keep this in your mind. So answer that you get will be in millions for the money spent, and the number of visitors will be in thousands. Now give an interpretation of the gradient of this regression line. How will you interpret gradient? See, first of all, before I go into this question, when I say y equal to, in a straight line, y equal to 2x plus 3, 2 is the gradient, correct? So what does gradient equals to 2 means? Gradient equals to 2 means when you walk 1 on the x-axis, you should walk 2 on the y-axis, correct? That is how the gradient becomes 2. It is 2 divided by 1 basically. Every one distance travel on x-axis, you travel 2 on the y-axis. This is what gradient means. It's the same thing here. So every distance travel on the x, the value of y. So every number of visitor here, for each visitor, how much money is spent. This is basically what is the interpretation of gradient. Similarly, if they ask you what is the interpretation of this, you can again correlate this with your y equal to mx plus c. What is the c there? The y-intercept. In other words, when x is 0. So the value of y when x is 0. So same the value of m when v is 0. When there are no visitors, how much money is spent and so on. Clear? This is how they will ask you in exam to interpret the values of the gradient and the y-intercept. Okay, let us check this. For each visitor, see, this is in thousands. Basically every 1,000 visitor, 0.740 million money is spent. For every 1,000, this much million. So for every 1,000 million, so the difference is 1,000 again, for 1,000 to million. That's why they wrote 740 pounds without the million. Clear? And now use regression, use this equation now to estimate the amount of money spent when the number of visitor. See, v in this formula is already in 1,000. So don't do the mistake of substituting this entire data in place of v. Remove the 3 zeros because it is already in 1,000. So you substitute 2200 in this, get the answer, and the answer that you will get for money will be directly in million. So whatever you get, the answer will be that much million. That's why the answer is 1161 million pounds. Comment on the reliability of this estimate. See, again, this is a very common question in your regression questions. They will ask you the reliability. What you do is you look at this data and see if this data is within the data you are studying. See, 2200, forget about the 3 zeros here. 2200 is definitely within the data that I am studying here. We have 2290, we have 23, we have 24, 24, 26, something like that. So it is in the data. Okay, so when you predict for something within the data or very close to your data, the answer that you will get will be reliable. Or it is called interpolation. Interpolation means within the data you are studying. And if it was outside the data you are studying, you say it will not be reliable. You'll write not reliable because extrapolation. It is outside the data that you are studying. Hope it is very clear. Let's go ahead. Okay. This is exercise 5C. They gave you S, X, X. Everything is, all the data are given straightforward. Again, I just wrote the formula again for your reference. Y equal to, this is the equation of regression. This is how you write the final answer. Y equal to ax plus a plus bx. We need to find a and b. The formulas are right here. So to find b, we just divide this by this. So to find b, we just divide 165 by 30. You get b. To find a, you rearrange this formula, make a the subject, mean of y minus the b. So that is why you should always find b first, because you will need b to find a. So don't find a first. Find b, you got b. Now you have your mean given to you. You have your mean of x, mean of y. So in place of mean of y, you substitute the value, which is 8. B, you got 5.5. Mean of x is given 4. Substitute, you got a. So we have b, we have a, we just resubstitute here. So y will be a negative 14 plus 5.5x. This is the final answer. This is our regression equation. Clear? Try to do this on your own. Let's go to the next slide. When you solve, you should get y equal to 2x as your answer. Okay. Now this is question number 12. Coats. How many coats of paint is given in this table, and the protection per year is written here. Okay, find the equation, interpret, and let us start finding the equation first. I have just written the equations here again for our reference so that we can see there is a this formula for sxx, sxy. Again, now let us, before we start this question, I told you earlier also, looking at the formula we can decide how many columns we need. So look at this formulas that we need. We need summation of x square. X and y are the parameters that they will give you that you're studying. So you have one column of x, one for y. The third column will be for x square, and there will be a column for xy. See, nowhere we need y square. So we don't need a column of y square like we did in correlation. So in regression, you will only need 4 columns in your table. X, y, x square, and xy. Let us see. See, you only need 4 columns. X, y, x square, xy. There is no need of y square. So the table is ready with all the totals written here. We need to find one by one b and then a. and the total, the mean of x, you add all the x, divide the 15 is the total, divide by 5, you get the mean total of y. You got the mean of x, mean of y. So now substitute the total of xy is 78.7, substitute 78.7 here, minus summation of x is 15, write 15 here, times it by 21.4, divide by 5 datas are there, 1 2 3 4 5, you put 5 here, you will get the answer. Same, you will get the answer for this. So now b is just that, you just divide this by this, so we got b is 1.45. A is the mean of y minus b times, substitute, you get a. So now the final answer, y equal to your a, just substitute a here, b here, x. This is your final answer for regression. So with this we answered first part of this question. There are part b, c and d. Let us take them in the next slide. Okay, this was our question and let us continue. This is the answer to part A. Let us continue. Interpret the value of b in this model now. Again, b means, b is the gradient, correct? What is the meaning of gradient? Gradient is for every value of x, the increase in y. So same thing you have to interpret in terms of x and y. So for every coating that you put, how many years of protection you get? This is, so you get 1.45 years of protection for every coating. Let us check. This is additional protection given in number of years for each additional coating you do for your paint. I hope you understood how to describe the gradient. Explain why this model would not be suitable for predicting the cost for 7. See again, this, whenever they ask you to reliability check if this number is within the data we are studying, no. We only studying for 1 to 5 codes. This is outside the data we are studying, so we cannot rely on this. This is extrapolation. The model would be unsuitable because 7 year lies outside the range, and hence you'll just say extrapolation. And the last part is just asking you, using your answer to part A, what will be the number of years of protection when there are 7 coating. Just substitute in the equation, that's it. So write the equation, in place of that number of coat you write 7, you get the answers of 10 years of protection you'll get extra. Next question. Now we are ending, we finished regression. Now we're just doing coding with regression now. Okay, the question says here, given that coding, there is a coding for p, there is a coding for q, has been used to get the regression equation p plus q equals to find the regression of y on x. Very simple. See, you start with this, that p plus q equals to 5. Start with that. In place of p, substitute the value of p, the equation for p, which is x plus 2. In place of q, y minus 3. Substitute, simplify, you get make y the subject. You got regression of y on x. That's it. Let's go ahead. Same, there is an equation coding for g, there is a coding for h, and the answer you got was h equals to 6 minus 4g. Now they want y on x. You do the same thing. You start with this, substitute. So you start with this, in place of h you substitute the value of h here, 6 as it is, minus 4 times g, in place of g resubstitute, simplify, make y the subject. This is your new regression of y on x. That's it. Next, the regression line of c on d is worked out using this coding given. So first they want you to find the regression of y on x. We do the same thing we did before. So you first find b, just divide, you get b, and they gave you mean of x, mean of y, find a. So you have b, you have a, just put in the formula. So this is your y equal to 3.5 plus 0.5x. Now they want the answer of d on c. Same thing, you start with this first. In place of y write d by 10, in place of x write c by 2, in place of x c by 2, simplify, make d the subject, job is over. Next, some data, same, it's the same thing. You can try this on your own. There is x, there is y, try to find sxy, this, find the regression of y on x, and then the same thing. Try on your own. Let us see the answer. So these are the data you will get. Equation, you will find all these values, you will get the answer for y. Just substitute, in place of y you will write w by 5, in place of x you write this, you will get the answer, and that's it. That is it. This is regression. I hope it's very clear. Goodbye.